Human civilization was referred to Homo sapiens. Homo sapiens has long dwelled and searched for answers that wasn't understood or unsure. It has always been a mystery, trying to figure out the beginning of life. Who created us? Where did we come from? And who is watching over us? This right here is my documentary, The Whole Truth by Peter Cezanne.
More than 4.5 billion years ago, the Milky Way galaxy collided with a nearby dwarf galaxy. This encounter hastened the formation of stars. Our solar system is a part of the Milky Way galaxy. Within the solar system, material circulation had been progressing. The water component from the outer region evaporated to make materials dry. Through this process, particles were zonally distributed, depending on their water content. The bipolar flow stopped, and with it, material circulation. Some regions around the Sun with high particle density appeared. Within these regions, collisions frequently occurred. Small particles gradually grew to become planetesimals. Planetesimals continued colliding with smaller particles and other planetesimals, eventually growing to planets, such as the Earth. A number of planets were moving in the same orbit. The early Earth collided with a smaller, Mars-sized planet. Debris from this impact eventually came to form our Moon. The Earth-Moon system, as we know it today, was in place. Countless planetesimals and icy planets bombarded the early dry Earth. Due to the bombarding water-enriched planetesimals, the Earth became enveloped by an ocean atmosphere system. Water vapor in the atmosphere produced rain, forming an ocean. The atmospheric pressure gradually decreased. The carbon dioxide-rich atmosphere transitioned into a CO2 ocean covering the water ocean. Carbon dioxide also combined with rock components and was transported to the bottom of the ocean through weathering and erosion. At this time, the ocean was still toxic with a high salinity and an overabundance of metals. It was too toxic to support life. Upwelling mantle displaced the oceanic plates above. Uplift of the plate by mantle convection caused horizontal slippage due to the weight of the plate. This is plate tectonics in action. The oceanic plate subducted under the lighter continental plate. Weathered sediments neutralized the ultra-acidic ocean. Heavy metals settled out and became fixed as deposits at the mid-ocean ridge. These deposits were transported through plate tectonics into the deep mantle. Gradually, the ocean became a habitable environment. By 4.2 billion years ago, a liquid core formed in the center of the Earth. Convection within the liquid core created a strong magnetic field surrounding the Earth. This geomagnetic field shields the Earth's surface from cosmic rays. The Earth's surface was nearing readiness for life. The early Earth, when the atmosphere prevented sunlight from reaching the surface. Primitive life was about to emerge underground, in the cave of a geyser. Uranium ore emitted large amounts of radiation, creating a diverse range of materials, and eventually producing the early building blocks of life. Water boiled and rose up to the surface, and the surface water flowed back down into the natural nuclear reactor. The temperature of the geyser water remained below 100 degrees, protecting the newly formed biomolecules. The underground environment was reductive, while the surface environment oxidizing. These conditions were necessary to synthesize biomolecules. In the Earth's Hadean eon, tidal forces were much more pronounced than they are today. Even lakes had significant ebb and flow of water, creating wet and dry cycles. These wet and dry cycles were one of the most crucial factors in producing the building blocks of life. Fatty acids came together, encasing the proto-life molecules. polymerization progressed under the wet and dry cycles. Eventually, protein-like basic materials that could act as catalysts were produced. These molecules circulated between the geyser cave and the surface environment. The interactions of these materials led to more complex biomolecules. Proto-RNA combined with enzyme-like basic materials and evolved into ribozymes, which had the ability to replicate themselves. This laid the groundwork for life to reproduce. Finally, these molecules were enclosed within lipid membranes, forming primitive protocellular life. This was the beginning of life. The Earth's plate tectonics, which had begun with the creation of its ocean, eventually destroyed its primordial continent and subsumed it to the deep mantle. By 4 billion years ago, the mother continent had disappeared, leaving life on the margins of a fragmented landmass. Inside the Earth, a dramatic change was about to begin. The subducted primordial continent descended toward the core mantle boundary. The wealth of radioactive elements in the primordial continent caused the uppermost part of the core to melt. By 4.2 billion years ago, the newly created liquid outer core was strengthening the Earth's magnetic field, protecting the surface environment against solar winds and cosmic rays. As a result, life could exist on the surface environment. The supply of energy and nutrients through material circulation is necessary for life. The essential mechanism to maintain life is an endless flow of electrons. The first proto-life couldn't survive very far from the nuclear geyser due to insufficient energy. Mutations, however, allowed life to evolve. The more resilient life forms were able to adapt and survive in harsh environments. This second stage of proto-life evolved to make use of the sunlight available on the Earth's surface. They developed a metabolism that converted light energy into electrochemical energy. Moreover, they used sugars to store energy for the sunless night hours. The source of energy for life on Earth shifted from nuclear geysers to the sun. Around 4.1 billion years ago, the ocean was still extremely toxic, killing off most of the proto-life forms within it. Nevertheless, some proto-life forms survived the extreme environment. They developed protective mechanisms to prevent the metallic ions in the ocean water from entering their protocells. This proto-life began coalescing into larger and more complex forms. Modern life forms use only 20 kinds of amino acids. This means our ancestors that used the same amino acids were the ones that survived the mass extinction. Evolution walks a perilous tightrope between continuing and ending. Unstable RNA evolved through ionizing radiation into more durable DNA, making it possible to reliably pass information across generations. And the third stage of proto-life was born. This was the beginning of prokaryotic organisms, the ancestors of today's archaea and bacteria. Oxygen, when unbound to any other material, can be toxic to life because oxygen destroys the reductive life body. Therefore, the first photosynthetic organisms would have been anaerobic microbes, which produced no oxygen. Life, however, adapted, taking advantage of oxygen. As a valuable source of additional energy. This development resulted in the appearance of cyanobacteria. Cyanobacteria produced oxygen, which crystallized into felsic iron-bearing oxide, reducing the iron content of the ocean. Still, the ocean was 5 times as saline as it is today. As the Earth's interior cooled, old slabs of the primordial crust, resting at the bottom of the upper mantle, fell into the lower mantle. Meanwhile, numerous mantle plumes ascended from the lower mantle into the upper mantle. This phenomenon is known as mantle overturn. Mantle plumes pushed the basaltic crust upward, generating landmass. This created shallow marine environments penetrated by sunlight, which allowed the cyanobacteria to flourish. The oxygen produced by the cyanobacteria gradually altered the Earth's atmosphere. On the ocean floor, ferric and ferrous iron were accumulating in the form of hematite and magnetite, creating a massive banded iron formation. By 2.5 billion years ago, the remaining banded iron formation was a few kilometers thick. This rapid decrease in iron content changed the color of the ocean to a familiar blue. Life began to change the surface environment. Such is the coevolution of the Earth and its inhabitants. This was an important step in life on Earth's long journey toward civilization. A collision between the Milky Way and a nearby dwarf galaxy produced countless glowing stars. Within a few thousand years, some of these stars ended in supernova explosions. A myriad of cosmic rays from the supernova deteriorated the Sun's heliosphere and bombarded the Earth. These cosmic rays helped generate cloud condensation nuclei, which produced more and more clouds until the Earth was completely blanketed with them. The thick cloud cover prevented sunlight from reaching the surface of the Earth. The Earth underwent a global glaciation event known as the Snowball Earth. This caused another global mass extinction. But once again, some life survived yet another difficult period beneath the ice sheet. Tiny life was protected by the Earth's massive circulating system. And the Earth is similarly held in place by the solar system and the expansive universe. Life is but one part of an enormous system. The prokaryotes survived the Snowball Earth, evolving into more complex life, such as endosymbiotic systems living together inside cells. They formed mitochondria and chloroplasts, which allowed them to get more energy from oxygen. A single prokaryote body could contain thousands of mitochondria. A nuclear membrane formed, protecting DNA from the oxygen-dense ocean water. DNA strands grew longer, retaining ever more genetic information. Life evolved into more diverse and complex organisms. At long last, the eukaryotes appeared. The eukaryotes grew 1,000,000 times larger than the prokaryotes. In theory, everything inevitably falls into disorder. And yet, life is orderly and increasingly complex. Life seems to continue evolving, undeterred by universal entropy. Plate tectonics caused small, developing continents to assemble into a single supercontinent called Nuna. As Nuna formed, its burgeoning landmass provided cyanobacteria with an expanding habitat in its lakes, rivers, wetlands, and estuaries. Cyanobacteria produces free oxygen through photosynthesis. At that time, however, most of the free oxygen produced was consumed in decomposing dead cyanobacteria, so very little free oxygen accumulated in the atmosphere. On land, however, dead cyanobacteria got buried under sediments. So oxygen that would have broken down their bodies instead ended up in the atmosphere. The presence of a large landmass helped increase the amount of oxygen in the atmosphere. As the total land area on the surface of the Earth increased, so too did atmospheric oxygen levels, dramatically. Over time, the Nuna supercontinent broke up into smaller continents. But once again, plate tectonics reassembled a supercontinent, this one called Rodinia in Equator region. Slabs of oceanic plates subducted under continental plates gradually accumulated in the mantle transition zone. Eventually, these slabs fell down into the core. The slabs cooled the outer core, changing the flow of electricity within. As a result, the core's dipole magnetic field transformed into a weaker quadrupole magnetic field. The Milky Way galaxy collided with a dwarf galaxy and underwent a transition into starburst conditions. Over time, these newly produced stars ended in supernova explosions, bombarding the Earth with cosmic rays. The Earth, with its weak quadrupole magnetic field, was heavily affected. Clouds covered the entire Earth, and ice covered its surface. A series of supernova explosions occurred. Long periods of extreme heat were punctuated by shorter periods of extreme cold. In the extremely cold periods, oxygen in the atmosphere fell to Archean eon levels, causing mass extinctions. These mass extinctions, however, created great opportunities for life to evolve into something completely new. Repeated influxes of cosmic rays and drastic fluctuations in oxygen levels. These environmental changes caused genetic mutations that accelerated the appearance of new species. The starburst period ended, and the Earth's core reverted to a stronger dipole magnetic field. Ongoing photosynthesis returned the oxygen in the atmosphere to previous levels. Meanwhile, the inner Earth was gradually cooling down. When the inner Earth is hot enough, the components of water trapped in minerals in the oceanic plates are released to the surface environment, and the seawater level is unaffected. However, once the mantle temperature drops below 650 degrees Celsius, minerals carry these water components down into the upper mantle. Meanwhile, on the surface, deprived of the components of water, sea levels gradually decrease. This is known as the leaking Earth phenomenon, which is inevitable on a cooling planet. This leaking effect moved 3% of all seawater into the deeper mantle. Sea level dropped by 600 meters. As a result, surface land areas grew, as did continental shelf areas receiving sunlight. A habitat for future life on Earth was being created. Rivers carried nutrients from the inlands down to the continental shelves. And the additional landmass significantly accelerated the buildup of oxygen in the atmosphere. These processes set the stage for an explosive evolution of life forms. Extreme climate changes continued, putting life on a path to new evolutional stages for survival. Life evolved with prokaryotes and eukaryotes living together as ever larger symbiotic organisms, compensating for each other's shortcomings and thriving as a whole. This greatly expanded the possibilities for forms of life. Life forms grew to 1 million times the size of eukaryotes and 1 trillion times the size of prokaryotes. The appearance of multicellular life was a critical leap for evolution. Another glaciation period came, and life suffered a mass extinction. With time, this glaciation also passed, and the global climate gradually warmed. Phosphorus and other materials essential for life circulated through the climate system and accumulated in the oceans. The animals of the Ediacaran period appeared at this time. Dickinsonia are iconic among the Ediacaran fauna. Some grew to over 1 meter in length. They were soft-bodied creatures with no shell or skeleton. They probably lived in warm, shallow marine environments around the Rodinia supercontinent. The supply of nutrients from the land was ever increasing, as was atmospheric oxygen. The amount of ferrous iron in the oceans increased. The ferrous iron oxidized, once again creating large bands of iron. Phosphorus and calcium levels in the ocean increased. Life evolved to use these elements, becoming animals with bones and shells. For example, the calcium helped protect Microdictyon from other animals. Their bodies used calcium to form a covering of hard scales. Life evolves to survive, making use of the elements in its environment. And the Earth's environment alters the shapes of life. The Earth entered another period of climactic instability. The Earth alternated between periods of extreme heat and extreme cold for tens of millions of years. These severe changes killed off the Ediacaran fauna. Nevertheless, new species were about to appear. Radiation from inside the Earth plays a significant role in the evolution of life. A continental rift is a place where a continent breaks open to expose erupting magma and radioactive elements. Radiation hastens the creation of new species and new branches in the tree of life. This is STEM evolution, creating new species at continental rifts. Life evolved separately on each small continent. When small continents recombined, their life forms crossbred. Different crossbreedings created new forms of life. Variation thrived. This is crown evolution. Continental collisions created more diverse surface environments. Bays and gulfs on large continents were especially well supplied with nutrients from upstream. Making use of these nutrients, Cambrian-era life forms diversified much more quickly. The Cambrian explosion created some 35 new phyla. These phyla became the foundation for the types of plants and animals we see today. There are three main ways that life evolved. Mass extinctions that eradicated many species. STEM evolution that hastened genetic mutations when continents broke apart. And crown evolution that hastened biodiversification when continents collided. So, the evolution of life is inextricably linked to environmental changes due to universal factors and continents assembling together and breaking apart. The ocean was more than 5 times as saline as it is today. 600 million years ago, the ocean gradually became less salty. Salt from seawater was relocated to the land in the form of rock salt. Decreasing sea levels made this possible through more exposed land. Even if seawater rose again high enough to reclaim the rock salt, most of it had become inaccessible, encased in sediments. The decrease in seawater salinity made the ocean more hospitable to diverse life forms. Estuaries and open seas welcomed new life. With increasing atmospheric oxygen levels, an ozone layer formed in the Earth's upper atmosphere. The ozone layer absorbs ultraviolet radiation from the sun. The land was becoming a more habitable environment. Algae was the first life form to transition out of the water onto the challenging land environment. This is why algae evolved before animals did. When insects appeared, they co-evolved together with plants. Appearing during the Cambrian explosion, fish were the first of the vertebrates, animals with backbones. Fish are the oldest vertebrate ancestors of us humans. As fish continued to evolve, Ichthyostega appeared, the ancestor of amphibians. Plants flourished, producing free oxygen through photosynthesis, providing the atmosphere with 1.5 times as much oxygen as it has today. Long after, the remains of these plants would become sedimentary coal. That coal would help fuel the remarkable breakthroughs for human civilization that started with the Industrial Revolution. Next, vertebrates equipped with lungs appeared and made their way onto land. The tree of life evolved, branching from fish to amphibians to reptiles and then dinosaurs and mammals, and eventually to humans. This guy hasn't found out about all that just yet. The solar system collided with a dark nebula. As the solar system passed through the nebula, the Earth was bombarded with cosmic rays. The Earth entered yet another frozen age. Plants were affected first, dramatically reducing the oxygen they supplied to the atmosphere. The surface environment reverted to an anaerobic state, like during the Archean period. The lack of oxygen killed off most species of amphibians, reptiles, and insects. Life managed to continue evolving, but faced another big challenge. Untouched by the evolutionary changes on the Earth's surface, anaerobic microorganisms had been thriving in oxygen-poor underground environments. The new oxygen-poor surface environment allowed them to re-emerge on land and in oceans. Their native habitat expanded across the globe. As oxygen levels rose again, these microorganisms evolved to adapt to the new environmental conditions, setting the stage for another phase of evolution. The emergence of new creatures that would evolve into humans was close at hand. On the supercontinent Pangaea, mammals and reptiles appeared and started evolving under a warm climate. While reptiles diversified into many varieties, mammals remained nocturnal, rat-sized animals. The mammals were in the shadows. With the appearance of dinosaurs, reptiles entered a golden age. dinosaurs prevailed against many other animal species and won the struggle for survival. High radiation magma is produced when a continent is split apart, and this is where stem evolution occurs due to induced mutation. Dinosaurs were at the pinnacle of their ecosystems. The pieces of northern Pangaea that had split later rejoined. This caused crown evolution. Amalgamation of continents brings the hybridization of life, and new species spread out to other continents. Dinosaurs flourished all over the world. In the plant world, angiosperms with advanced reproductive capacities appeared. Angiosperms utilize animals to help with pollination and thus flourished. On the other hand, the habitat of gymnosperms was reduced. Primates, the ancestors of humans, appeared at the rift of the Gondwana supercontinent. Via stem evolution, new species appeared among the rodents, such as rats. With time, Gondwana split into South America and Africa. After South America was isolated, the primates there evolved into the New World monkeys. On the African continent, the primates evolved into the Old World monkeys. After the Indian subcontinent split off from Antarctica, primates on this continent evolved into the lorises. Primates evolved independently on each continent. And in this way, many species of primate appeared. A large-scale Pacific superplume pushed the Pacific plate up and raised the sea level. Lowlands fell below sea level, and the total land area decreased. Rising sea levels segmented the continent, providing isolated environments for individualized morphological evolution. A universe-scale event had changed Earth's surface environment. The solar system collided with a dark nebula. The Earth was entirely covered by clouds. Global cooling progressed, catastrophically damaging ecosystems. Finally, a meteorite 10 kilometers across fell on the Yucatan Peninsula. This event was the final trigger to cause the mass extinction of dinosaurs. The fate of the Earth's life is deeply connected to the events in the universe.
Human beings and animals breathe the same air, carry same blood cells, require food and certain environments to survive. But they got their vast differences. Human beings acquire skills that cannot be performed by any other living creature that roam the earth. For instance, we create communication through speaking. Also, we came with some extraterrestrial abilities to adapt, to realize, to create, and much more. Being more advanced than any other living creature among us. And still, studies are being done on how much more could a human brain do. Animals, on the other hand, make me believe so much in oneness with something. Animals being created of this earth, as showed earlier, are so connected that they don't need any kind of technology to inform them what is coming, or how will the weather form, or what the desires after birth. The connection to earth itself is the teacher of anything created from earth. And that's the reason animals, insects, bacteria, and plants that form around us every day doesn't need anyone or anything to tell them what to do to survive. It's basic joint connection instincts, like a child love for their parents, mothers especially, being the one that nurturing them. That's a connection that living things has with the world. At the end of chapter 1, it was spoken that Earth was hit by a giant asteroid. Not sure of the accurate size, 10 kilometers approximately, but big enough to wipe off some life on Earth. This is what we call the Big Bang. To some, people class the Big Bang as the classic end of life on it. But it was not. The Big Bang was in fact the entry to human species on it. See, there was always planets before Earth. Some planets that exist today are much larger than Earth, and some much smaller. We were on a planet unknown to man today because the planet was in fact destroyed, like many other planets would have faced, having to battle with other planets and large rock particles with the push and pull gravity in space, making them target practice for their own Big Bang, just with planets not surviving, also bursting into asteroids, scattering particles throughout space, with one of those particles targeting Earth, which was the cause for the Big Bang. Back before our previous planet destruction, with a lot of time in our hand at that time, we created a way to escape the destroying planet, just as we will do with Earth in time to come. On our way to Earth, the destroyed planet exploded, taking out a lot of lives in the process, and also lots of human race. The remaining of races on a voyage to a new world came to Earth after the destruction of their previous planet, which cleared anything in its path as an asteroid rampaging through space. Also, with one directing to Earth. The Big Bang.
Under the burning sun, among the sand dunes, somewhere in the Sahara Desert, you're walking in search of an ancient treasure. Finally, you find a strange rock in the sand. It's big, looks like a large piece of black coal or rock, but something shiny on its surface makes the rock unusual. This unique find is the oldest thing that has ever been discovered on our planet. This rock was born long before Earth appeared in outer space. The unusual meteorite was found in 2020 in a remote area of the Sahara Desert. Scientists have analyzed the isotopes of magnesium and aluminum on the stone's surface and found that its age is about 4.5 billion years. At the moment, this is the oldest sample of magma from space in history. It belongs to a small protoplanet that didn't have time to form completely. It happened a very long time ago when our solar system was forming. Many huge asteroids were floating in space. Some of them were formed into huge celestial bodies, which later became planets. The big rocky planets were absorbing the smaller ones. The rock was part of a little protoplanet that just began its formation, but another huge asteroid destroyed it. The planet shattered into billions of pieces. Some of them became part of other planets. Some flew outside the solar system, and one piece that had been wandering in space until our Earth was formed. After that, it hit the planet's atmosphere and fell into the territory now known as the Sahara Desert. The rock was discovered in 2020, but the erosion of extraterrestrial rocks shows that it could have fallen much earlier. This ancient thing weighing around 70 pounds has several pieces of different meteorites inside. In simple words, it's a volcanic rock consisting of lava. It has cooled, solidified, and crystallized. That's why you notice the glitter. Scientists hope that further study of the rock will help to learn more about our solar system foundation. The biggest asteroid discovered in the U.S. is the Willamette. Its size is 84 square feet, and its weight is more than 15 tons. This is half the weight of a bus. Several people can fit on the surface of this outer space object. But the coolest thing is that it's not a rock like most meteorites that were found. Willamette is made of nickel and iron. This massive piece of metal was discovered in 1906. Now, the huge rock is kept at the American Museum of Natural History. The largest meteorite ever found is Hoba. It's located in Namibia, and people have never changed its position because it's too heavy. The weight of Hoba is 60 tons. It's heavier than a tank. The next space-related event occurred on February 28 in southwest England. On this day, a huge flash lit up the sky. Then there was a loud crash. Several residents opened the doors of their houses and noticed a black sooty spot on the lawn. They immediately guessed what had happened and reported the discovery to the British Meteorite Observation Network. If you ever find a meteorite, report it to some geological research or space center as soon as possible. The longer a space rock lies on the ground, the faster it loses its value. Rain, dust, snow, wind, scorching sun, all these factors damage the surface of the meteorite. It makes it difficult to study the celestial object. The meteorite found in England looks like coal, but it's way softer and more fragile. It most likely used to contain frozen water. The rock is part of a huge asteroid that plowed through outer space when our solar system hadn't fully formed yet. They found a unique combination of minerals inside the rock. It can help scientists learn more about the origins of the solar system and life on Earth. Now we're heading to Germany, to the small town of Nördlingen. A huge ancient meteorite's hidden here. It's very difficult to notice it unless you know the secret of this town. You're walking along the cozy little streets and looking at the buildings with beautiful architecture. You spend the whole day there and don't find anything that reminds you of a meteorite. To solve the mystery, you need to get out of town. So you climb a high hill and see that the city is located inside a pit. For a long time, locals were sure the house was located in the crater of an extinct volcano. If you look at the houses from a certain angle, you may notice an unusual shining coming from them. In the middle of the 20th century, a group of geologists came here and immediately declared that the crater doesn't look like a volcanic one. The town was built on a huge crater left by a meteorite. The huge celestial body fell here about 15 million years ago. It was so hot that the carbon bubbles inside instantly turned into small diamonds. When people were building this city, they didn't know they were using expensive stones, since the diamonds were hardly visible. The locals never attached importance to the fact that the city walls shine unusually in the sun. Now they believe this place was built from diamonds that had fallen from the sky. Our next stop is in the UK again. This time the rocks are of an earthly origin. The famous Stonehenge. People place circles of rocks here in a certain order. Everyone knows about this archaeological monument, but no one knows the reason for its creation for certain. Another construction built out of mysterious rocks was discovered just 2 miles away. It's called Superhenge. It's bigger, heavier, and takes up more space. Each plate here is 15 feet, which is about the height of 2 floors. Once, the stone stood vertically and formed a huge semicircle. But someone pushed the stones over about 4,500 years ago. It was a college prank. No, not really. That's why they couldn't be detected for a long time. Scientists still can't solve the mystery of Superhenge, but they believe the standing vertical stones were part of some huge monument. Some other amazing rocks are located in the south of Costa Rica. There are big ones, the size of a human, and there are smaller ones, the size of bowling balls. And they all have a perfectly round shape. These giant rocky spheres were created by people. It must have taken years of polishing using stone tools to get the perfect round shape. These balls are incredibly heavy, but can easily roll like a basketball. All the rocks are of a different age. Some of them were created about 2,500 years ago. Most of them are made of molten volcanic magma. Until now, scientists don't know for what purpose these stones were used. They were found in different parts of Costa Rica, near big cities. It's possible that ancient civilizations installed them specifically to show the greatness of local kings. Also, many experts believe the rocks were used as a tool for studying astronomy. The people who knew their purpose of the rocks had disappeared, and the history of the stones was lost along with them. Let's finish our journey with the coolest archaeological find. You're walking through the desert of Peru and climbing a low hill. You look down and notice the surface of the hill is covered with strange lines. You walk far away and see a huge cat on the hill. Such a drawing is called a geoglyph. Its length is around 120 feet, which is about half the size of a Boeing commercial jet. Archaeologists discovered the giant cat in 2020 and found out that it had been created somewhere between 200 and 100 BCE. This huge drawing is part of a mysterious group of different pictures. In addition to the cat, there are other animals, plants, and fantastic figures. All of them were found in the desert of Peru. The kitten was found by chance. Archaeologists didn't see it at first because natural erosion on the hillside had almost erased the silhouette.
After coming to Earth, there were no exact landing spot, which gave us reasons to land anywhere on it. Hence, why there are so many pyramids all over the globe. We were able to settle seeing that there was much of a threat to harm us, and this caused us to grow. Little we had on Earth was just resources we came with, and also small living creatures of the Earth that survived the Big Bang. Being on Earth was a challenge for humans, especially being limited in population. But there was so much form of race that as much died, a lot lived. That's how we are so much races of people still. Yet, with many still dying on Earth, being unable to adapt to the challenges of Earth and its atmosphere, You can see drawings and hieroglyphs of many different ancient people in pyramids and museums according to where you go in the world, and the ancient knowledge and technology they would have left behind to build a substantial level in life. Back then, before we even had current, we came with the ability to survive. Throughout the years, we learned to adapt, map out, and make maps to mark out our starting point so that we can explore. Probably in search of food, probably change of atmosphere, or probably in search of other lives. Certain beliefs in animal philosophy at that time caused certain individuals to wear masks and animal fur and even gain skills. For example, fighting techniques. Their technique were good and a necessity for weather changes, environmental changes, and also to survive through hunting. Stories have been told, and story that was broken down and interpreted after a while started to differ due to the lack of knowledge from constant moving, and after some time, the wars for settlement. This is how religion and beliefs in gods came about. And so we live until today, forming colonies of army, judge masters, and civilization today. Still seeking knowledge on how we can best explain life. But with it all, in search of the aliens and in search of the answers, I brought you the answers for life and the fact that human beings on earth are the terrestrial beings, the aliens of the earth. Thank you for watching. Like and subscribe if you enjoyed it. If you learn anything or have any questions, you can leave a comment.